find your position versus time graphs from the assignment where you played with the little constant velocity cars, assignment 1.5. You know from this experience that we can talk about the average velocity as the initial plus the final velocity of the object moving divided by half, because we took two counts. But in this case, the initial velocity and the final velocity were the same thing for our cars. Leaves us with your average velocity, which we can show as the mean, or with a line over the V, as our position or distance traveled in a ratio with time. The distance that you traveled is measured in meters, and the time unit was in seconds. Your new task will be to take this data and find the average speed or velocity for each time interval that you measured. Your existing data table might look a little like this. You have your initial time, first second, second section, second, third second, and let's say our position was at the what we call the origin. Then in 1 second it was at 5, 11, or 16. And your unit might be centimeters or meters, depending on how you recorded it. We want to create a new data table. This one is going to look at time in seconds in a ratio with the change in position in a ratio with time. Or what did we just say that was? That was the average speed. Let's take a look at how to do this. At our initial time, there is no change in position, so you won't have a data point there. For time number 1, we went and found ourselves at 5, and we started at 0. So our change in position that is our distance divided our 1 second minus 0, or 1, would give us our new piece of information of 5 meters per second. For the second one, we're going to look at our change in position. We wound up at 11. We started at 5. This was time number 2 and compared with time number 1. Or we wound up with 6 meters in 1 second. One more time. For the third data point, we're going from 2 to 3, or 11 to 16. So we wind up at 16 meters. We started at 11, and that gives us 5 meters. And our time, 3 seconds, 2 seconds from 3 seconds, gives us 1 second. So we wind up with 5 meters per second, 6 meters per second, and 5 meters per second. Some groups took their position data measurements after 2 seconds or even 3 seconds. If this is you, you're still going to do the exact same thing. Let's look at this data table. So we wouldn't have an initial change because this is the starting point. But after 2 seconds have passed, we have a change in position versus time for our average velocity of, we've gone from 0 to 10 in 2 seconds. So we would have 10 over 2. And for the next one, we wound up at 21 when we started at 10, and that took another 2 seconds. And so we would wind up with 11 over 2. To go from the 4th second to the 6th second, we would have we wound up at 30 when we started at 21 between second number 4 and second number 6, and we would have 9 halves. Let me make this look a little more cohesive here. That would be for my 2, that would be for my 4, and that would be for my 6. And again, this would be centimeters per second. And of course, you know that's 5, and you know that's 5 something, and you know this is 4 something. And you can do, I just don't have a calculator right here with me. What's 11? Centimeters per second. You're going to be asked to plot this data on a new graph for both the fast and the slow car. You're going to show the best fit trend line, find the equation for that line, and we're going to learn that the slope has a meaning called acceleration, and the area under this line has a new meaning. That's the distance traveled in that time. So that's where we're headed, and that's what you need to come to class with for your next, after your Unit 1 test.